Hey guys, welcome to OG's Wealth of Math. In this video, we want to see a proof of the angle between two line segments. So if you've not subscribed to my channel, you can do that. Share my link, make comment on my video, click on the like button, leave your comment. Thank you, and let's get started. Now, let's assume we have our y and our x coordinate, and then we have a line which goes this way. Let me call it L sub 1. And then I have another line, which is L sub 2, and I have an angle. Let me call the angle theta. Angle theta is in between line L sub 1 and line L sub 2. And let's say L sub 2 make an angle with the horizontal. Let me call it theta sub 2, and then L sub 1 makes an angle with the horizontal, theta sub 1. And then I want to find the angle between the two line segments. But let's assume we have a line, a single line, like this. And want to find the angle, of the slope. Obviously, we all know that the general equation of the line is y equals mx plus c. But we want to find the angle of the slope. Now, let's say I have 2 points on that line. Let me call it x sub 1 comma y sub 1, and then on the second point x sub 2 comma y sub 2. Now I know you know how to find the gradient from here, because if I project this, I have x sub 1 here, I have x sub 2, then on the y coordinate I have y sub 1, and then I have y sub 2. Now we can see that on the x coordinate, the distance is actually x sub 2 minus x sub 1. Similarly, on the y coordinate, it is y sub 2 minus y sub 1. Now, if I want to find the slope, which represent m is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that gives us the slope. I know you're very familiar with the slope equation. Now, we want to find the angle of the slope. Let's say theta. You can see theta to the horizontal. Now, if you recall from your SOHCAHTOA, we want to find the angle theta. So if we look at it, this is the opposite adjacent. Opposite adjacent represent tan. So tan theta is actually opposite, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that shows that tan theta is still the same thing as m. So for a single line, the slope of a line, or the angle of the slope, is actually tan theta equals m. So to get theta, it will be the tan inverse of m. All right. Now, the reason why I did this so that you have a clearer picture of what I'm going to do with this. All right. Now let's assume. So let's go back to this. Now, if you look at this, now I want to find the angle in between line segment L sub 1 and L sub 2. Now that tells me that since I have 3 angles here, I want to express theta in terms of theta. I want to express theta in terms of theta sub 2 and theta sub 1. Now if you look at this, this is a triangle and this is an exterior angle. If you remember, the exterior angle is equal to the sum of the two opposite interior angles. So exterior angle is theta sub 2 equal theta plus theta sub 1. So if I take theta sub 2 to the theta sub 1 to the other side, I'm going to have theta sub 2 minus theta sub 1 equals theta. So theta is actually theta sub 2 minus theta sub 1. So I've been able to express theta in terms of theta sub 1 and theta sub 2. Now, if I don't want to do that, I can just say, oh, this is a straight line. sum of angle on the straight line is 180 degrees. So 180 minus theta sub 2. So this will become 180 minus theta sub 2. If I sum, the sum of angle in a triangle is 180 degrees. So if I do theta plus theta sub 1 plus 180 minus theta sub 2 equals 180 degrees. So sum of angle in a triangle. So I want to express theta in terms of theta sub 2 and theta sub 1. So I'll subtract 180 from both sides. So theta plus theta sub 1, 180 minus 180 is 0, minus theta sub 2 equals 180 minus 180 is 0. So if I take this and that to the other side, my theta will be theta sub 2 minus theta sub 1, all right? So that's another way to express theta in terms of theta sub 1 and theta sub 2. Now, if you recall from what I did, for a single line, the slope of an angle, I said tan theta is equals to m, all right? So if I want to, so similarly, if I want to find the angle of slope L sub 1, so I'm going to say tan theta sub 1 equals m sub 1, all right? So L sub 2, if I want to find the angle of the slope for L sub 2, it should be tan theta sub 2 equals m sub 2, all right? Now the next thing I want to do, this is my expression, and now I want to express this. I'm going to, so I have this and this, so I'm going to take the tan of both sides. If I take the tan of both sides, I'm going to get tan theta equals tan theta sub 2 minus theta sub 1, all right? Now, so if you recall from your from trigonometry, if you recall that tan theta sub 2 minus theta sub 1 will give me tan theta sub 2 minus tan theta sub 1 divided by 1 plus tan theta sub 2 tan theta sub 1, all right? Now, if I plug, let me bring this expression back. Tan theta is tan theta sub 2 minus tan theta sub 1. So you can see that this thing, this represents this whole thing. So I'm going to plug in all of this here. So I have tan theta to be tan theta sub 2 minus tan theta sub 1 divided by 1 plus tan theta sub 2 tan theta sub 1, all right? Now, finally, so I can pull this as the absolute value of all of this. So finally, tan theta will be tan theta sub 2 represent m sub 2. So I will say m sub 2 minus tan theta sub 1 is an m sub 1 divided by 1 plus tan theta sub 2, m sub 2, m sub 1. So the absolute value of that. So this is the angle between two line segments. So it's just a proof. So thanks for watching my video. You can always subscribe on OG's Wealth of Maths. Share my link, share your views, make comment. Thank you and have a great day. Bye-bye.